All right, so this is my advanced volumetric lighting material function. So essentially what this is a set of two blueprints, one of which uses the point light and one uses the spotlight. And it allows you to have a material function or a light function type of effect on your light that actually blocks out the volumetric lighting as well, or it masks it. So the standard light function will essentially mask out your light pattern. And it can be animated. You can use all kinds of texture samples for it. It can be video, all that good stuff. But what it will not do is it will not occlude or mask out the volumetric lighting from that light. So the way the light injects into the fog volume. This blueprint allows it to do just that. Now the cool thing about this is it does retain all the features of the existing light actors because it still uses them. So it uses the point light and the spotlight. So you still get your indirect lighting intensity, source radius, volumetric scattering intensity, all of that good stuff. And on top of that, it still uses the built-in volumetric lighting system of Unreal Engine. It's not adding in any new functionality as far as that goes. It just adds in the functionality of being able to mask out that volumetric effect based on a material. So in this case, you'll see that I have a few different examples in here, most of which are animated, but there are some that are static. So if you want to use this as like a standard light cookie that also masks out your volumetric lighting effect, you can do that. In the front two examples, you'll see we have a point light and a spotlight, both playing the same pattern on repeat. This one is actually a video, which is being rendered to a video texture and then read by the material. Now this particular one is just a black and white pattern on loop, which looks like this. I did slow this down to 15 frames per second just to make the effect a little bit more noticeable in the demo, but you can obviously use any resolution, any frame rate that you want to. One of the big things to keep in mind is obviously the temporal nature of the volumetric lighting effect. So if it moves too fast, you're just going to get a blurry mess. So just keep that in mind. Now, another thing to keep in mind is scalability will affect this. So if you go and change your scalability down to high, for example, you'll see that the volumetric effect is still there. This is more of a volumetric lighting quality adjustment. It doesn't really have to do with the blueprint itself. The blueprint will just work with whatever it's given. If I go down to medium, you'll see the volumetric effect is gone completely, simply because the scalability settings are what determine that. So for the purposes of the example, I'm just showing it in cinematic quality, simply to show it at the highest quality. But this is just how the volumetric lighting works. It's not a specific limitation to the blueprint itself. And you can obviously adjust the scalability on a per effect type or quality basis, so shadows, post-processing, all that stuff. So you could go in and keep just the part that controls the volumetric lighting higher if you want the best quality and dumb everything else down, depending on exactly what you're utilizing this for. So if I go through here, as you can see, these two initial examples are actually a video rendering to a texture being played on a loop. This is just a static pattern. So all the rest of these that you see are actually just static textures that are being animated through the material instance itself, which I'll show you in a second. And you can see how it's masking out the volumetric effect, not just the light itself. So you've obviously got a line grid here. You have an alphabet back over here. This one is actually the Unreal Engine U. This one is just set to static, so you can get a better idea of how it's masking out the light and the volumetric effect from the light. And then going over here, this is actually just a single bar of white that is on a panner. So it's just panning in the material itself. This one is a spotlight, so you're only going to see it in the cone of the spot. And then over here, this is a point light, so you'll see it in the full sphere of the light doing the exact same thing. Now, another thing to take notice of is even though this is occluding based on the mask of the light, it will still also retain the standard volumetric features. So in this case, this piece of geometry is also occluding the volumetric light effect on top of it being masked out with the blueprint. Okay, and then over here we have a checkerboard pattern. This one is panning. Now on this side it's panning basically based on a spherical shape. That's why it looks like it's rotating here. And then here it's panning within the cone of the spotlight, right? And you can see the effect of the masking of the volumetric effect. Now this one you'll notice also has a light function inside of it. So I'm utilizing the volumetric light function as well as a standard light function. So you can still mask out inside of your volumetric mask. Okay, this one over here, this is obviously a dot grid. Once again, this one's just on a pan, but because it's being essentially wrapped to a spherical light, it's rotating, and here it's panning. Over here, this is actually using a flipbook technique. So this is essentially a water caustics type of a pattern. And a flipbook is essentially, if you think of rows and columns, you have a certain amount of rows across and a certain amount of rows down. It's going for each section of those rows. Let's say you have 4 across. Every X amount of seconds, it's going to each one of those rows and columns and then creating essentially a flipbook animation from that. So it's a single texture that it's reading from doing that. So you can use flipbooks in here as well. And this is just a diagonal line pattern. And once again, because it's being wrapped spherically, it comes out looking more like a hypnosis type of a swirl. And this is what it looks like just being projected on a point light, or sorry, a spotlight. And there's another good example showing that it's still being occluded by the static mesh that's in here, even though it's masked on top of that. Okay. So I'm going to bring up the material instance itself. So the outliner is organized very cleanly. Inside of here is where you'll find the actual blueprints for the volumetric light function. You'll see I have them separated into point and spot. This is all the same blueprint, just duplicated over and having the materials and some of the parameters changed for each one. Down here, you'll see this media playback blueprint. This is essentially just telling that video to play on a loop at all times. And this is mostly just for demo purposes. So you can see right now the video is actually paused because I loaded up the media player, which kind of supersedes this. So you can play the video in a couple different ways. If you load up the media player here, and you go in here and just double click on the video, it will start playing that video. Okay. And then when you close that, the video will stop playing. This blueprint by default, if I open this up real quick, will play the video. So when you load the editor, this should be playing by default. If not, you can just load up this blueprint and it will play because it's based on a construction script to tell it to play the video that's there. Okay. And you can obviously trigger the video however you like. This is also an embedded video, but you can use any of the media framework ways of playing a video, which there's a bunch of documentations for online, if you decide to use a video to use for this material function, or for this volumetric lighting function. So I'm going to go over and I'm going to start with, let's just go over to the Unreal logo to start with. So if we go over to the blueprint itself, I'll load that up. And I'm going to load up the material for it. So obviously these are material instances. They're all based on a single master material, and then the instance is just figuring out what's different based on its usage. So on this one, as you can see, if I go into textures, minimize all this, you can see the texture I'm using is the Unreal Engine U. And if you click on this little find icon here, you can find the rest of the textures here. So this folder is just the patterns that I've included with the examples. And once again, you can replace this with anything you like. The one thing to keep in mind is it is sampling basically black and white values because it can only be visible or non-visible, right? So I do have a dithering technique in there as well, which I'll show you in just a second. But if I want to swap out the texture, I can just go in and do that. So let's say I want to use this instead, or I want to use this, or I want to use this one, right? I can put in any patterns that I want. And once again, it should just be a black and white texture. Now this one currently is static, it's not moving, but if I wanted to change that, I can do that, which I'll show you in a minute. But I can also go and adjust the tiling of this. And as you can see, it updates in real time because it is masking out the volumetric effect in real time. I can also go in and adjust the rotation of this if I want to. And if I wanted to rotate on a different axis, I can do that. So right now it's set to 0.5, which means it's rotating in the middle of the texture. But let's say I set this to 0, it's going to be one of the corners of the texture, right? So you can kind of control where the rotation happens. It's just a little extra added freedom. Usually you wouldn't really need to use that, but you can. And if you want to, you can also set this to local or world coordinates. So you set this to world coordinates by unchecking that. Your scale is going to be based on world position, which means if you move this around, it's going to be based on the position in the world, not the light itself, or the local position of the light. Set that all back to where it was. Now if I go down into mask, I have a couple other options in here as well. I can invert the mask. So right now the U, which is white, is where the light is coming through. But if I want to invert that and make it so the U is what's masking out the light, I can do that as well. And if I want to, I can also dither this. So if I go down here and check use dither, give it a second to update the shaders, I can then go in and adjust values for this dither. So I can actually adjust essentially the intensity of it by adjusting this threshold value and then the randomization value. This is essentially a temporal dither on the mask, so it's still not rendered as translucent, but it gives you a similar effect. Now, because this specific mask is not blurred, the dither effect is only going to affect it as a whole. But if I go in and grab this texture here, which I'll show you the difference. So, okay. So we've got these lines here, which are just solid. And we have these lines here, which are blurred. Now, these are very low resolution, only 256, but obviously, depending on the resolution you utilize, you can get different results. Now, because this has a gradation between the white and the black values, that temporal dither is going to have a greater effect on it. So we go in here. And then now as you can see, this looks very rough here because it's interpolating the dither between just black and white values by default, or the gradation. So it's either going to be, it's just going to have a hard edge, right? There is no dithering going on or any blurring. So we go in here and use dither and then enable that. You can see now that it actually feathers out those edges, and I can tweak the threshold and randomization values here and get a little bit more of a dithered mask. And as you can see, that still affects the volumetric light how you'd expect it to. It's basically rendering through all that pointillization that's going on of the mask. Okay. So I'm going to set that back to where it was, and I'm going to set this back to the Unreal logo here. Close that out. Now if I go over here, let's say I go to this one, which has a bar on it. So this is the texture being used for that. It's literally just a solid white bar where the light is coming through. And you can see that being represented here. Now there's another one where I can go in and let's say I want to invert the mask. So everything except for that bar is where the light comes in. I can do that. I can also go in and adjust the tiling, the rotation, everything like that. So let's say I bump up the tiling a little bit. I get multiple bars there. And you can adjust the tiling however you like, and you can do it in real time or enter values directly. I'm going to set that back to where it was. Now for the animation part of things, if I go down into animation, you can see that I have the ability to use a flipbook if I want to. It will not work on this texture because this texture is not designed as a flipbook. The other one over there is, and I'll show you that in a minute. But if I go into pan speed and rotation, I basically have the ability to adjust the pan direction and speed. So I set this to 0. There's no motion. Let's do like 0.1. I'll do 0.5. I'll do 1. Now, obviously, you still have the temporal stability of the volumetric lighting, which makes it blurry if it moves too quickly, but you still get the effect from it. So just keep that in mind and use it accordingly. And then I can also have it move in different directions. Now with this particular pattern, because it's a bar, it's essentially, this would control moving it up and down if you look at the texture, so you're not really going to notice the motion, but I'll show you on another material here. So if I go over to this one, for example, okay. So keep in mind both of these are using the same material. So if I bump up the movement speed, you can see how that's working. And if I change it here, right? So let's say I set this to 0.1 there and then 0 there. You can see it over here, it's basically expanding outwards. Once again, that's because it is wrapped around a sphere on the left, and on the right, it's basically wrapped around a plane projection. So you can get some really cool effects with this. So the one on the left, if I change this back to 0.1, it's going to rotate and expand out. So you can do some really, really cool stuff with this, right? I'll leave that back where it is. And once again, just like with the rest of it, I can go in and adjust the tiling however I like. And the tiling will obviously affect how large the pattern is, which is going to affect how it cuts out the volumetric effect, right? Rotation, all that stuff still works the same way. All right, so that covers the material instance setup itself. I think it's pretty straightforward, and you get the idea of how that works. Now, what you'll notice here is these two lights, they have a light function, a standard light function applied to them. So if I go in here and I select this asset, you can see that it is a light function attached to it. I'm just going to collapse everything except for this. Now, if you go in and expand the light category of the details for the blueprint, you'll see that I have a bunch of parameters exposed. So one of them being a light function. So if I go in here and find this, you can see it's a light caustics. So this is essentially using a flip book to go down rows and columns of a single texture, and it creates an animation from that. So I'm going to get rid of that so you can see what it looks like without the light function. Then I'll apply it back. Now, once again, a standard light function you can apply to a light right out of the gate in Unreal Engine, but it does not include the volumetric effect from the light, which is what my blueprint does. You can also go in and apply an IES profile. This essentially allows you to replicate the shape, intensity, and all that of a real-world light, or you could just use it as a light cookie if you wanted to, but you can apply that here as well. You also have your overall intensity value that you can adjust and all that, which I'll show you in a second. So I'll go over here and do that on this light, just because it's a little bit easier to see, I believe, in the video. So I'm going to select this light. Now in here, you see that I can go in and adjust the mobility. So I can make this static, stationary, or movable. I can adjust the projection material instance. This is essentially the light function for the light. So I can go ahead and swap that out with anything that I want, and it will update. And once again, these are the material instances that I showed you earlier, and all those parameters and everything inside of those. Now below that, you also have a projection orientation. Now this only exists on the point light because the spotlight doesn't require it. But essentially this allows you to rotate the pattern around separately from the material instance. So material instance essentially gives you U and V rotation, where this will actually give you a rotation in 3D space. So the best way to think about it is the point light is essentially a spherical light, so it's projecting in all directions. And this is rotating the pattern around that sphere. Right? So you can really get the projection to look how you want it to. And you can combine that. It's essentially just the two first values that are going to do anything. This one will not change anything unless you have those rotated, because this would be your z-axis. Once again, you can go and apply your light function. You can do the IES profile here. You can adjust your overall intensity of the light, obviously. You can go in and adjust your color of the light, just like you'd expect to be able to. You can adjust your attenuation radius. So this is how far the light casts. If I turn off game view mode, you can see how that looks. You can also go in and adjust your source radius. So the source radius is effectively where the light emits from, the radius of the light. So this has a couple of different effects. So one of which is the specularity of light. When it reflects on a floor or something like that, will be represented by this, this size. And then it will also affect the shadow casting from this light. So as you can see, as I make it larger, the shadows are getting blurrier and all that good stuff and creating more of a penumbra. And it's not just on the light pattern itself, but also on this piece of geometry here, the cube that I have. If you pay attention to the shadow from it, you can see it gets blurrier the larger the source radius is. That's because the light is casting from a larger area, which will essentially start overlapping where the light rays go and making it the shadows fuzzy from it. Now another thing you can do is if you bump up the source radius and then you bump up the source length, you get more of a capsulized shape. Now this is useful for things like neon lights or fluorescent light bulbs, where they're long rather than standard light bulbs. So the best way to think of this is the representation of whatever light source you're using in your scene. So for example, if you have this for a standard light bulb, you might want to make it 3 or 4 inches wide with your source radius to make it seem like the light is actually emitting from that bulb, right? And it'll just have more realistic lighting. Now your soft source radius essentially takes the specular reflection of this light and blurs it out. By default, it's just going to be a hard cutoff of whatever the shape and radius of your light is. But if you adjust the soft source radius, it'll feather that out. You also have your indirect lighting intensity. So this is the bounce lighting from this light, how much it bounces light off of other objects when it hits them. And then you also have your volumetric lighting intensity, which this is how much this light actually injects into the volumetric fog of the scene, right? set that back to where it was. Now everything else for these light actors will act exactly how you expect, so you can still move them around like you would normally. You can also, obviously, since this is a spotlight, you can rotate it and point in any direction you want to, all that good stuff. It can still be attached to objects, all of that. So let's say you had a car with headlights, or a gun with a light on it, or just a flashlight, whatever it is, you can still use this effect on that as well. All right, hopefully a lot of you find this useful. I've had many requests to release this. I built a version of this in Unreal Engine 4, but the technique I used for it was broken with the lighting system in Unreal Engine 5, and I never got around to updating it until just recently, and I found a workaround for it. So it still works as intended, actually works better than the original version did, which I never released. So hopefully you guys find this useful.